we are going to be working with something called an empirical formula. All right. An empirical formula is a formula where you have the smallest whole number ratio. Now, you've been doing that all along in terms of creating ionic compounds. But when it comes to molecular compounds, we've always done molecular formulas. Okay. So now we're going to be looking at something called an empirical formula. So for example, if we had glucose here, okay, this is its molecular formula. This is its empirical. Because everything's divisible by 6. This is the empirical formula of this. And if you're given the percentage composition by mass of a compound, a molecular compound, you can actually from that figure out what this formula is. And so I'm going to show you how to do that today. And then with one additional piece of information, you can figure out what this is. So we're going to determine how to do this. We've been given the formula and gone to the percentages. Now we're doing the opposite of that. And I'm going to give you the steps for doing that. Okay. So here are the steps. I'm going to take you through this one and quote the steps as I'm doing it. Okay. So if you're given percentages, you're going to assume that you have a 100-gram sample. So that is step 1 and 2. We are going to convert the percents to grams. So all I have to do, if we have a 100-gram sample, I just change the percent signs to grams. So I have done steps 1 and 2 so far. Then I'm going to change those grams into moles. So I have to take the gram mass that I have now, and I'm going to divide by the molecular mass off the periodic table. So for nitrogen, that is 14.0. That's going to get me into moles of nitrogen. For oxygen, it's 63.16 divided by 16. That's going to give me my moles of oxygen. So this is going to be 2.63. This is going to be 3.95. So what I've done so far is I've just converted my percents into grams. I've then divided by the molecular mass off the periodic table for each item and turned those grams into moles. Everybody with me so far? All right. The next step then, according to our rules up here, are that we're going to divide each mole value by the lowest mole value. So which one of these is smaller? This guy. So I'm going to divide everything by that lowest mole value. This, of course, will equal 1. And this will equal 1.50. Make sure that you always put this value out to the hundredths place. Round to the hundredths place. Now, sometimes these come out to whole numbers. If they do, you can skip over to step 6. But if they don't, you need to decide something to multiply this by in order to get it to the smallest whole number possible. So what can I multiply this by to get to the smallest whole number? 2. So I am going to next multiply by 2. But if I do it to that one, I have to do it to both items. So that's going to give me a 2 here, and it's going to give me a 3 here. And then these become my subscripts. So I take my element here, which is nitrogen, so N2O3. This is my empirical formula then for this substance. Easy enough? All right, let's try another one. Everybody caught up on that one? Ready to go? Anybody not? Anybody need me to pause? Okay. So if I'm given percents, I'm going to assume that I have a 100-gram sample, and I'm going to turn my percents into grams. Step 3 then. I'm going to take those gram values and I'm going to turn them into moles. So 35.98 grams of aluminum. I'm going to divide that by 27, and that's going to give me moles of aluminum. And then 64.02 grams of sulfur divided by 32.1 is going to give me my moles of sulfur. This is going to be 1.33 here. And this guy is going to be 1.99. All right. Now, after we're done with that, and this is the step that people forget, okay? The next step is you've got to divide by the lowest mole value. So in this case, this is the lowest mole value. So and I have to do it to both terms. So this is going to equal 1. This is going to equal 1.50. That's a sad looking 5. Let's try to fix that. There we go. Next step then, I'm going to find the lowest whole number to multiply this by to get this to a whole number. So what is that going to be? 2. But I have to do it to both terms. So this will become a 2. This will become a 3. Then I grab those, Al2S3. So these become my subscripts then. And that's an empirical formula. Okay? I want you to try to do the next one yourself. Now, this one, they've already got it into grams for you. So you're just going to skip down to step 3 and convert to moles. Nickel, 58.7. 4.38. 12. Were you able to get this for your formula? Oh, wait a minute. Did I screw that up? I think I screwed that up. I think this is 2 and this is... No. Okay, I gotta just write this out. So nickel, I ended up with 0.179. And then, yeah, I did screw that up. Carbon and nitrogen, these both ended up being 0.365364. And I'm going to divide by the lowest mole amount. So yeah, I did screw that up. So it should be C2N2. Or if you can identify this as a polyatomic ion, cyanide, you might have written that out. But I'm happy with this. I'm very happy with this. This makes me happy. This makes me absolutely delighted. Okay. Everybody good? See how to do those? Are they making sense? Okay. All right, so we are going to move on then to molecular formula. Molecular formula is just one extra step. So you're going to take and you are going to determine for me the empirical formula of caffeine. You should be able to do A. So the first step in finding the molecular formula is to find the empirical. So you're going to do A, and then I'm going to show you how to do B. So do another sample here. They've already got these into grams, so all you have to do is start at step 3 and turn them into moles. And I guess I better do it longhand myself because I screwed up the last one. So who's to say that I won't screw this one up otherwise? Hey, good morning. How you doing, honey? You looking for Lennon? He's right there. Spending some time with me, Lennon? Yep. I got 28.85. I'm going to divide that by 14. My oxygen, divided by 16. And let's do a little hydrogen here. 5.20 divided by 1. 49.47. 12. 4.12. 28.85. 14. 2.06. 16.48. 16. 1.03. And 5.20. All right. Did you do okay on it? It's easy once you understand the steps, right? Okay. So, in order to find the molecular formula then for this caffeine, we are going to take this and we're going to add these up and determine what the molecular mass of the empirical is. Then we're going to take the molecular mass divided by the empirical mass, and those are going to become our new subscripts. Okay, we're going to multiply these by that value, and that'll become our subscripts. So my molecular mass they gave up here as 194.19. We've got to figure out the molecular mass of this guy. So how many grams per mole this guy is. So 48, 28, 16, and 5. So that's 97. So I'm going to take this and divide by 97, and I get a big ol' whopping 2. Anybody not know where I got this value from? You need to back the train up. Okay. So I took 4 carbons at 12 each, which is 48. I took 2 nitrogens at 14 each, which is 28. I took an oxygen, which is 16. And I took 5 hydrogens.
Oh, that's the molecular mass. Okay.
Yep. I'm going to get the molecular mass, or I'm going to get the empirical mass. This is the mass of this empirical formula.
Yeah, empirical mass.
Okay. The molecular mass they gave us in the problem right here.
Yeah.
So this is the empirical mass right here. Or molecular, I mean. This is your empirical. And I divide those two out and I get a 2. Then you multiply the subscripts by that 2 to get the empirical. Or to get the molecular. Ugh, keep stumbling over that. So C, 4 times 2 is 8. N, 2 times 2 is 4. O, 1 times 2 is 2. H, 5 times 2 is 10. And this is the molecular formula then for caffeine. And if you want to see what the structure looks like, I have it on my little mug rug here. So, because I'm truly addicted to caffeine, you guys. It's a rough one. It's not good. All right. So I want you to spend a minute trying to do this one. Find the empirical formula of this malic acid, and then I want the molecular. Hmm, 41.3912. Hydrogen, oxygen. All right, so divide by the lowest mole amount. So there is my empirical. So my molecular is that. Anybody not get that for their empirical and molecular?
I was not even finished. I'm not even finished.
All right. If she's not finished, you guys work on the next one if you're done with this one. Haley's already got it. Are you understanding it okay?
Yeah, I calculated just
It's all there. Does it need to be charged? Oh, that's not good. Are you gonna need one for math today? Just keep that one until. Just keep that one until the end of the day then, because otherwise you're gonna have problems all day long.
Wait, what did you get 29 from?
It's the molecular mass, so 12 plus 1 plus 16 equals 29. Yeah? Make sense?
Yeah, I just added raw.
$71.02. Is that for the examples? Yep. Okay. I think we might be able to finish that video today then. All right, what you think? Ray, you good? You need more time, honey?
Yeah.
Okay. Well, you guys have homework to do. Start working on your homework until I can start the video, okay?
What did I do? Is that a 5 or a 3? How did you even get a number that high?
For the bottom number here,
Yeah.
this, I had 107.9 for my silver. I had carbon, which is 12, and 2 oxygens. 16 times 2 is 32. So I added that together to get 151.
Oh, wait, perfect double. Yeah, okay. Yeah, there you go. Okay.
All right, I'm going to get that video started then. We left off here at 115 on your video. Oh, do I have still have this volume off?